Alright, today is lesson 83, solving linear and quadratic systems on a graphing calculator. So most of this lesson will be done on Desmos. It's an app, it's free on your on your iPad, on an iPhone, and I even think they have it free on Android. And it's also free on the computer. So you can use it anywhere for free. So you know how they have like graphing calculators that you buy that are really expensive? You could do that, which some teachers only allow you to use that, but this app we're going to use is an excellent app. It's called Desmos. And so today what we're going to talk about is a system of equations where we draw like a line. Let's say we draw a line and then we have like a quadratic graph there as well, and we're going to see where do the points cross, because sometimes you want to know that, right? For example, you might want to know in science, you know how the Earth rotates in an ellipse or a circle revolves around the sun, yes? What if there was a comet that also has a trajectory that crosses the Earth's trajectory? Wouldn't we want to know if it's going to crash, right? Do y'all agree? So scientists use this all the time when they look at the trajectory of a comet passing by the Earth. And you know those news articles that say, oh, this asteroid is humongous and it's going to cross the path of the Earth within so many 100,000 kilometers. Yes?
There's one in like 2027.
Uh-huh.
And it's like going to come by, and if it passes through like a certain area, and like 10 years later it's going to hit through.
Oh, really?
We're all gonna die.
Because like the gravitational effect of the Earth is going to like change its course just enough to like crash into the Earth.
Oh, wow. Okay, so, well, that's good to know. And scary. All right. Well, I just want to let you know it was good to teach you. Good luck. No. Okay, anyways, not to, I don't know if that's true, but it could be. And they actually do those, they do study that because it is important, because what if there was, an actual danger that's going to come, they would actually put emphasis to prevent that danger. So, yeah, that's what we're doing today. That's an application, but you might even use it, like, let's say you are trying to look at let's say you're at a shooting range with your gun and you want to shoot a disc. Anyone ever go to a shooting range before? Okay, and what are those things called? Skeets, right? You know, the skeets path is kind of like a quadratic graph. When are you going to hit it? Well, you could either follow it, or you might have a couple of chances to hit it. You have it on the way up and on the way down. Does that make sense? So we're going to look at that. There's all sorts of applications. And if we're looking at things specifically, if we want to calculate things like scientifically, if we're looking at how do we calculate it so that we can get the exact points of impact, then we could look at it there. Do we have another question around here? Okay, so we're going to use a graphing calculator. The steps are super easy. Using Desmos, graph each function, and then find where the intersecting points are. Okay, so this Desmos app, you could find it on your iPhone, iPad, so iPhone or iPad or whatever you have. You could also get it on the Droid, and then also you could go on to your computer or on the internet. It's all free. It's the same thing, and it's super awesome. And I think it's called www.desmos.com. Okay. So we'll use in our class we're going to use the iPad app since it's already installed. But if you need to ever do homework, you can go to the Media Center and use the computer there, or do it at home, or you could just download it if you like on your phones. Okay. Like I said, the app is free in and of itself. As long as you have access to the internet, you should be able to download it. Okay, so here's a couple of graphs, okay? Now, I know this looks really scary. I'm going to write this down up here. Y is equal to negative 5/3 x minus 5, and y is equal to 3x squared plus 6x plus 6, okay? This looks scary, right? What kind of graph is this first one? Linear. How did you know it's linear? It's not squared. It's x to which power? X to the first. Did y'all hear? Okay. What kind of graph is the second one? Why is it quadratic? Can you all show me predict what a linear graph would look like with your arms? Straight out. Okay, right? Like you're flying a plane. Show me what a graph of a quadratic should look like with your arms. Okay, you do this with all your... Okay, good. So that's the concept. Now, looking at up here, I'm going to go a little slow. So See if this works. Pause the recording here. Okay, so you would go to your Internet Explorer, whatever it is, and you're going to go to Google, or you can even just type in www.desmos.com, and then, but you have an app in front of you. We're going to use that. Just watch what I'm going to do right now. Okay, and when you get to desmos.com, it gives you like, oh, you know, some other stuff. But click on Launch Calculator if you're from home, or if you have the app, you just click the app, and it'll just take you to this screen right here. I'm going to hit the lights. Okay. So can someone read off the first equation to me? Y equals, so watch what I'm going to do. Y equals, keep going.
Negative 5/3.
So I'm going to write negative, and then open parentheses, 5/3, which is 5 divided by 3, right? You see that?
5/3 x.
X, you see I went outside the parentheses for X?
5.
Plus 5, okay?
Minus.
Minus or plus 5?
Minus.
Thank you. Okay, that's the first one, okay? That's the graph of it. See how easy that is to graph? And watch me do the second one. I'm going to double click underneath. Can someone read the second one, please? Y equals what?
3x squared.
3x, 3x, and then we're going to go down here to the squared button over here.
Plus 6x.
Plus 6x,
Plus 6.
plus 6. Okay, so let's say this was the trajectory of a comet right here. And this is the Earth, maybe, like the ellipse, maybe. I don't know if it's going to actually look like that, but let's just say it was that embellished. Will this line cross this here? No. So when it doesn't cross, it means there are no solutions, okay? So then our answer to number 1 is no solution. Okay? So number 1 is they don't cross here, so since this line, again, let me write this down. Since this line doesn't cross with this graph here, there is no solution. Okay? And I know that's the case because I know that my graph, no solution. No solution. Okay? Does that make sense? Okay? Continuing on. Let me pause it. Okay, so number 1 is no solution. Now I've got the second one here. Y is equal to 3/2 x plus 3. Now I'm going to write this one down up here, okay? So y is equal to 3/2 x plus 3, and then y is equal to negative x squared plus 8x minus 14. I hope this one works. This one should work. I hope it works. Okay? So, going to my decimal graph. I'm going to move over here. Okay, and I'm going to delete the old ones, okay? I'm going to always start off with a fresh calculator. Can someone read me the first one?
Y equals 3/2.
Okay, y equals, how do I do fractions? I need to do what? And in what? Someone said the P word? In parentheses, 3/2, right? And then where do I put the x? On the inside or outside? Keep going.
Plus 3.
Plus 3. Okay, that's my first graph. Second graph. Okay, what's the second graph? Y equals what?
Negative x squared.
Negative x squared
Plus 8x.
plus 8x
Minus 4. Yeah, minus 14.
minus 14. I hope this works. Oh, let's just pretend it was minus 4. Okay, I'm going to change it to minus 4, okay? Now this one, notice what's happening. I'm changing it to minus 4 because, yeah, they cross, okay? And watch what happens. I would use my fingers on my iPad, but I would move it up here, and I'm noticing, look, here's the vertex right here, right? 412. So if you ever wanted to find the vertex easy for homework, you could go on your graphing calculator to find it. But how many times does this graph cross or does the quadratic graph cross? Twice, right? So how many answers should I have?
2.
2 answers, right? There's an answer here, which is 1.363, 5.044, and then there's this other one right here, right? So there's 3 answers here. Or actually only one answer. Or I'm sorry, not one answer. 2 answers here, right? 2 points where they cross. Okay, so on your homework, you would just write these as ordered pairs, right? It's going 1.363, 5.044, and then the other one is 5.137 and up 10.706. Now these numbers seem all like random, right? You okay? What's wrong?
I hear someone breathing really loud.
Oh, you hear someone breathing. Stop breathing loud, okay? Okay, anyways. Does this make sense? So what if you were like, let's say you were playing, or you were shooting a skeet, right? And someone threw it up really high and came down really, really far down, and you were pointing at the same direction the whole time. You were pointing your gun in the same direction. How many opportunities do you have to shoot the skeet? Twice, right? How far away is it from you? From this point, it's 5 point. Well, you could calculate how far it is from you. Okay, based upon that. Okay, so turn your neighbor, explain how do we graph it, and how do we find solutions, and explain how sometimes there aren't any solutions. Ready, set, go. Okay, so we're going to go back to our presentation here. Oop, wrong one. And I'm going to just go to the next slide here. Sorry, it looks a little smaller on the screen. Okay, so here we go. We got two more equations, so let's go to our Desmos app. We're going to put in this number 3 here. Number 3 is right here, okay? We got y is equal to negative x squared plus 8x minus 19. And then y is equal to the following, okay? Take a moment to do that. Ready, set, go.
Yeah, I got it now.
All right, here's the example. What if this was like an under-ocean, an undersea mountain here, right? There's a mountain right here. Submarine, right? It's coming down. Will the submarine crash into the mountain?
No.
No, it won't. Okay, so that's another example. They use models. They say, okay, we need to have the submarine descend with this particular slope, negative 1/2, right? Okay. All right, let's do another one. A couple minutes to write it down. Make sure you delete the old ones. You could press X on the old example. Check with your neighbor, make sure you get it correct. Y is equal to x squared, so we're going x squared, right? Minus 8x plus 20. Where did my graph go? Oh, it's way up there. Okay, next one. Then we're going to do the next one. It's y is equal to 2. Okay. Did it cross at all?
No.
No, it didn't. Okay. Does that make sense? Now, what if my y was bigger? Look what happens here. What happens if y becomes 3? Will it cross? Look up at my screen, please. I just changed from 2 to 3. Look what happens. Did my line cross with the quadratic? No, what happens if I put 3? Okay, what happens if I put 4? Is it crossing?
Yes.
How many times is it crossing?
Once.
Once. Good. What's the name of that point? Can you change your y is equal to 4, right? So isn't that the same line as our... What kind of quadratic is this? Does it have a minimum or maximum? What's the minimum? What's the equation for the minimum? Y is equal to 4. Remember that? Okay. So you might have an example like this where you have a line crossing at one perfect point, okay, with vertex. Alright? What's that? Y is equal to 4, that's right. Raise your hand if you're getting all these right the first time. Raise your hand if you want to do a couple more together. Okay, let's do a couple more. Here we go. We could do it. Here we go. I'm going to go back to our slides here. Moving back to number 5. Go. Number 5. Okay, so these last two have no solution.
What? Oh.
No solution. What? Okay, no solution. I'm zooming in all the way here.
I said bigger, not small.
What do you mean I zoomed in?
Don't zoom in.
Oh. So you want to like this? No solution.
Yeah.
Okay, anyways, I'm being silly. Okay, sometimes the graphs will cross perfectly. The concept is, though, and this is the concept that you need to know. We use the technology, you practice that, that's good to know. But the concept is, the answer is where the lines cross, okay? Does that make sense? Remember systems of equations? Remember how we graphed two lines and they crossed?
Yeah.
Okay, that was one solution. Over here we could have more than one. We could have two solutions, right? Depending how the graph is. And again, we use this in real life all the time when you're thinking about trajectories and the paths of objects. Okay? That concludes this lesson.